Hello and welcome to the System Design for Parallel Programming. So in this session we would be actually going to deep dive into the interaction between the CPU and GPU. Now we have covered the CPU architecture and the GPU architecture separately, but now we are seeing that this both of the architecture that we have covered, it's connected over to this PCI bus, as you can see in the center. So that is the PCI bus. So this PCI bus is which connects the CPU and the GPU. Now, as you can see, the DRAM has a special memory controller. And what happens? This direct memory access for a GPU, there is a capability that it can directly interact with this DRAM without having to disturb the CPU cores. So basically what we are trying to achieve over here is that any of our computation which we need to carry out for a data transfer, we don't need to involve any CPU cycle. So CPU can keep running its instruction set without any intervention or without any blockage for a GPU data transfer. So let's see how it would flow when you typically write your program. So the typical words which would be used is, so whenever we are coming with the CPU designs, we call it as a host. So this host would be nothing but the CPU would be referred as a host, and the DRAM which is connected to the CPU memory controller directly will be called as a host memory. Whereas in a GPU we will call with the term device, which would be known as a device, and this global shared memory can be called as a device memory. So that is for a wordings for a GPU. So in the programming perspective, you need to think that not everything can be executed directly with the GPU because it is not designed for a general purpose. So what exactly happen is that the initial level instructions and the scheduling of a job, everything has to be done by the CPU. So take an example. If you want to add some number which is x plus y, however it looks simple, but now if you imagine that x is a vector and y is also a vector, and you need to perform addition. So there is a multiple operations. Now if you start imagining with the CPU, then what would you typically be doing is there would be a one-to-one mapping, and you will start calculating and producing the results sequentially. But in terms of a parallel programming, what we aim to do is we want to parallelize this process. So at a one time, if we are adding this one, then at the second time we will be also adding the second values. And in this kind of cases, so if your x and y, so the data is coming from somewhere else, maybe it is coming from some network, some file storage, or user input. Now in this event, this data which we want to transfer to the GPU, the CPU needs to run some part of a code to gather the data and instruct that this data requires to move from the host to the device. And for that instruction, you can see that there would be some piece of a code which would be the host code, and there would be some piece of a code which would be called as a device code. And then only we can be able to successfully execute the program. So in the case when we are trying to launch a device code, it would be known and called as launching a kernel. Yeah, it is not a Linux kernel which one may typically be aware of. In the GPU, this is called as a launching a kernel, which would be taking this instruction and executing onto the GPU. And so for that purpose, so whenever the instructions are coming and there is a data need to be transferred. So without any involvement of the CPU, once the instruction is passed to the scheduler, so the data from the memory controller would be directly accessing the GPU memory using the DMA engine. And you will see that data from DRAM will be copied to the global shared memory. So, and that would be coming over the PCI bus. So there is a PCI bus which is connecting the CPU architecture and the DRAM, and the DMA engine would directly help here to transfer the data from the host memory to the global shared memory, and then scheduler can start executing instruction for every streaming multiprocessor, and eventually we'll get our result ready. So once the every result is ready, computation is completed, so we would have to specify like where and how we need to get the data back. So for example, if the results have been rewritten to the X, but that result is currently in the global shared memory. So now we need to pass that data for a user. So either we need to display on the screen or we may need to display onto some file. So in either of the case, what would happen? So this data which has been completed with the calculation will be transferred to the memory controller again without any intervention of a CPU cores. So now it is passed to the host memory. Now this host memory controller, so based on the instruction, either it can display or there may be another IP also which will be like a storage. So it can store the data onto the non-volatile memory, which is like a storage disk, either a hard drive or a SSD. So it's based on the operation. But this is how typically the program would work and the data would flow.